Hello everyone! Today, I'll be showing you a Java implementation of a stack using a linked list. I have already created a project package and our main class. First, we have this inner class called stack node. Think of it as the building block of our stack. Each of our stack node will have two parts: an int data to store the actual value we want to put in our stack, and a stack node next to keep track of the next element in our stack. Let us now add a constructor. It is a way to initialize the data within a node when we create it. Now let's move on to our first method, isEmpty method. This method is pretty straightforward. It's here to tell us if our stack is empty or not using an if-else statement. If the root is null, it means our stack is empty, and we return true. Else, if root is not null, that tells us that there are some items in our stack, so we return false. Moving on to our next method, push method. This is where we add elements to our stack. We start by creating a new stack node called new node with the data we want to add. Now, we will use again our if-else statement. If our stack is currently empty, we make our new node the new root. In other words, our new node becomes the top of the stack. Else, if the stack already has items, we need to do a bit of a shuffle. We create a temporary stack node called temp to hold the current top of the stack. And then we make our new node the new root. And now we connect the new node to the rest of the stack by setting its next to the previously saved temp. And lastly, we print a statement that confirms that the data has been pushed onto our stack. We are now heading to our third method, the pop method. This one is all about removing elements from the stack. We start by setting up a variable called pop with a value of integer.mean_value. This is like a placeholder just in case the stack is empty. Now, using our if-else statement, we will check if our stack is empty. We will then print a message to let us know if the stack is empty. And if there's nothing to pop, pop remains at integer mean value. Else, if the stack isn't empty, we grab the data from the current top of the stack and assign it to pop. Then, we make the root point to the next element in the stack, effectively removing the top element. Finally, we return the pop value, which will either be the data from the top element if the stack wasn't empty, or our integer mean value if our stack was empty. So before we proceed, I have noticed here that I have made some typological error. Always remember that Java is a case sensitive, so be very careful with typing. Moving on to our topic, another method we're gonna use is our peek method. This one is about checking the top element without removing it. First, using if-else statement, we need to check if our stack is empty. If the stack is indeed empty, we'll print out a statement to inform the user that the stack is empty. Else, if the stack isn't empty, we simply return the data of the current top element. This is us checking without altering the rest of the stack. And lastly, our main method. This serves as the entry point of our program. This is where we'll demonstrate how our stack implemented as a linked list really works. First, we create a new stack as linked list object, and we're calling it SLL. Next, it's time to add some elements to our stack. We're going to push in the numbers 10, 20, and 30. We use the SLL.push method to add these numbers onto our stack. Now, let's see what happens when we pop an element from the stack. Here, we're using SLL.pop. The pop method takes out the top element and also returns its value. So in this line, we're popping the top element and then printing it out. And lastly, we want to check what's on top of our stack without removing it. So we're going to use the peek method. With SLL.peek, we're looking at the top element without actually taking it out. Let us now again scan our code to check for any errors. And if there's not, we can now proceed to test run it. Let us see if we have accomplished our goal output. So there we go, we have our final output. We have 10 push to stack, 20 push to stack, 30 push to stack, 30 pop from the stack, top element is 20. So we have accomplished our goal output. So that's it, guys. Let's take a moment to recap what we've covered. We defined our stack node class to represent the elements in the stack, and then we were able to build our own stack operations: push, pop, and peek. We saw how the push method adds element to the stack, maintaining the last in, first out order. The pop method allowed us to remove and retrieve the top element from our stack. Also, with the peek method, we could sneak a peek at the top element without altering the rest of the stack. And lastly, in our main method, we put our stack to the test. We created a stack, pushed in numbers, pop an element, and peek at the top. So there you have it, a journey through the mechanics of a stack implemented as a linked list in Java. I hope you learned. Hello everyone, so today I will be showing you an infix notation to postfix notation conversion. Infix notation is a method of writing mathematical expressions and formulas in which operators are placed between operands. So this is the usual way of us doing a mathematical operation. So we have left operand, operator, and right operand. While in our postfix notation, the operator follow our operands. So we have left operand, right operand, and the operator. Moving on, I will be giving you examples of infix notation, and together we will convert it into a postfix notation. So we have here our first example. We have A plus B times C. Our left operands are A and B, while our right operand is C. We have operators plus and multiplication. Now, to convert it to postfix notation, we'll put first our left operands, which is A and B, and now C as our right operand, and now our operators. Since we're following PEMDAS rules, our multiplication operator comes first before our addition. So our answer will be A, B, C, and our multiplication operator, and now our addition. Now let's move on to our next example. We have open parentheses A plus B close parentheses multiplied to open parentheses C minus D close parentheses. So this is our first operation, A plus B. Now we will take its left operand A and its right operand B and its operator, which is addition. Now let's set aside this multiplication operator and let's proceed to our right operation. So we have C as our left operand, B as our right operand, and our minus as our operator. Let us now convert it to a postfix notation. So for our left operand, we have A and B and its operator addition. And for our right operand, C and D and its operator subtraction. And for our operator, we have our multiplication operator. We have our third example. We have A plus open parentheses B times C close parentheses. So let's take first our left operation and its left operand A, and let's set aside our operator. Now our right operation is B times C. Let's take its left operand B, its right operand C, and its operator multiplication. Let us now convert it to a postfix notation. So we have our left operand A, our right operands B and C, and our operator multiplication and addition. I have again another example. We have A times open parentheses B plus C close parentheses minus D. Let's now take our first operation. We have left operand A and its operator multiplication. And to our next operation, we have left operand B, its right operand C, and its operator addition. And we have our next operation. We have its operand D and its operator subtraction. Let us now convert it into a postfix notation. Let us take our left operand A and B and its right operand C and its operator addition. And now let's take our letter A's operator, which is multiplication. And now we have our operand D and its operator subtraction. We have A exponent open parentheses B plus C close parentheses. Let us now see our first operation. We have its left operand A and its operator our exponent. And our next operation, we have left operand B, right operand C, and its operator addition. We will now then convert it to postfix notation. So let us take first our left operand A and B and our right operand C and its operator addition. And now let's take our letter A's operator, which is our exponent. So that's it, guys, for our infix notation and postfix notation conversion. Thank you.